You're going to need to, from time to time, when you're adding and subtracting fractions, make those fractions improper. You're going to have to use it when you divide and multiply. When you make a negative fraction improper, you make it improper first, and then you deal with the sign. Okay? To make it improper, you multiply the denominator times the whole number, and then you add the numerator. The best way I could think of to show you that. So 8 times 4 is 32. 32 plus 3 is 35. And the denominator stays 4. Then, if the mixed number was negative, the improper fraction is negative. If the mixed number is negative, the improper fraction is negative. Because they have to be equivalent. But this says write it so the negative is in the numerator. So multiply the whole number in the denominator, then add the numerator to that product. Okay? Plus the order of operations tells us do multiplication and addition, right?
Yeah.
Okay? If it's a negative mixed number, it's going to be a negative improper fraction, but we don't attach the negative until we've made it improper.
Yeah.
Okay? The numerator of a fraction is 9, the denominator is 6. If you still struggle with knowing which is the numerator and which is the denominator, denominator starts with D down. D down. Put the denominator down. So the numerator has to go up. You guys make that connection? D, denominator down. Okay? Well, none of these are 9/6, so we're going to simplify. Okay? To simplify, here's what I'm going to do. I'm going to be very consistent. I'm going to write the numerator in prime factored form. I'm going to write the denominator in prime factored form. And then I'm going to divide out any common factors in the numerator and the denominator. How long did it take? How long did it take me to do the prime factorization? Not very long. 3 halves. But we are looking for the fraction that is not equivalent to all the other ones. So 3 halves we can mark off. Can we mark off anything else? Well, this is improper, so make it a mixed number. So 3 divide the numerator by the denominator, and then it's the remainder as the numerator and the divisor as the denominator. So 3 halves and 1 1/2 are the same thing. So now look, if we can use a process of elimination now, 2/3 is the reciprocal of 3 halves, isn't it?
Yeah, but
So there's no way that the 2/3 can be the same as the 3 halves. Does everybody see that?
yeah.
And we know the 3 halves is the same as the 1 1/2. So the 2/3 is the one that's not equivalent to the other one.
But wouldn't 18/12 be the same on 9/6 also?
Yeah.
Because you can use
Multiply by 2. Yes. Okay. That's another way to look at it. Add. Guys, look for this clue today. Reduce, simplify. If it tells you reduce or simplify, you're probably going to need to do that. Follow with me? If it tells you to reduce or simplify, you're going to need to do that. Okay? To add fractions, you add the numerators together. So 47 plus 29 is 76. You keep the denominator the same. So 76 148. But anytime, again, just like I told you, if it says simplify, 90% of the time you're going to need to simplify. You guys got that? Do and use the prime factorization to simplify. It's much faster than trying to find the least common multiple. And what else do we got? We got 148 divided by 2 is 74. Divided by 2 is 37. See, dividing by 2, you can do that mentally. So write 76 as 2 times 19. and 148 as 2 times 2 times 37. Then what? Because we are simplifying, then what?
Then you eliminate the ones that they're uncommon.
You divide out the common factors in the numerator and the denominator. What are we left with? 19/37. Use the prime factorization. In the end, it'll save you time. Sometimes you have to slow down to speed up.
That's confusing.
Woo! Remember way back when we made that chart and we had the plus sign, we had words that meant addition, and we had the subtraction sign, we had words that meant subtract, and multiplication and division and equals. Where does difference go?
Subtract.
Subtract. So it's -7/9 minus 4/9. When working with these fractions, change subtraction to addition. -7/9 plus -4/9. Subtracting a positive is adding a negative. Now once you do that, you have a common denominator, right? So you can add -7 and -4. When you're adding and the signs are the same, you add the distances together and attach the common sign, right? No, it should be 11. Sorry. Yes, it should be 11. 11. And then how many times does 9 go to 11?
Once.
How many left over? And if I put 1 and 2/9, I'm going to be wrong. Anybody know why I'm going to be wrong?
Because it's negative.
Because it's negative, because if the improper fraction is negative, the mixed number is negative. Now, I don't know if it's going to be -11/9, say 1, or -1 and 2/9. All with me? Lots of crazy stuff going on with these fractions. Oh, look what this says. 90% of the time, if it says reduce or simplify, you're going to need to reduce or simplify. Okay? Now we're adding and the signs are different. What do you do when you're adding and the signs are different? You end up subtracting the absolute values of the distances, right? 13 and 5/12 minus 4 and 11/12. Now, in the fraction world, you move away from the integer world and you have to work in the fraction world. And here's what's so important when you work with mixed numbers. If you are adding or subtracting, you add or subtract the numerators first. In the real number, not in the real number world, in the whole number world, can you take 5 minus 11? No, it's impossible. So what are we going to have to do? Borrow, rename, regroup, whatever you want to call that. Okay? To do that, you make the whole number 1 less. Anybody else know it? Then you know what to do next?
10 to the right?
Well, we got to add something to the numerator. You add the numerator and the denominator together because it's like you're adding 12/12. So 12 and 17/12 minus 4 and 11/12. First of all, we had to borrow because you can't take 5 minus 11. That's why we had to borrow or rename. Okay? When you do that, you make the whole number 1 less, and you add the numerator and denominator together, get the new numerator. Now we can subtract. 12 minus 11 is 6, and 12 minus 4 is 8. Now we got to go back to the originals and decide, should it be negative or should it be positive?
Should be positive.
Because the one with the greater absolute the greater distance from 0 was positive, right? And so we got that. But if you try to use 8 and 6/12, you won't get anywhere. You got. What's the number we can divide 6 and 12 both by?
6.
Big number, bigger.
6. 11.
6 is half of 12, isn't it? I would expect you to recognize that. You're all very smart.
Sometimes.
Subtract. Now look at this. Why am I exaggerating that or emphasizing that?
Because that's adding
What?
the absolute.
So negative 5 4/5 plus 7 2/5. Subtracting a negative is adding a positive. But now we're adding and the signs are different.
So it's still be positive.
So what do you do when you're adding and the signs are different? You're adding and the signs are different, what do? Okay, well you subtract. Right? So you got to do 7 2/5 minus 5 4/5. Do we need to rename, borrow, regroup?
Yes.
Why are you saying yes?
Because the numerator with the 7 is smaller than 4.
Okay. 2 minus 4. Can't do it in the whole number world. So how do we rename the 7 2/5?
You take 1 from the 7, and then you add the 2 and 5.
You add the 2 and the 5 together. 6 7/5 minus 5 4/5. Then you subtract the numerator. 7 minus 4 is 3. 6 minus 5 is 1. Now we got to go back to right here and decide should it be positive or should it be negative.
Positive because 6 is more than 5. 7 is positive.
Okay, because the positive number is a greater distance from 0 than the negative. So 1 3/5. So we got a lot to think about here, a lot going on.
And it was wrong because you can't reduce.
Okay, well in this case, I said 90% of the time, if it says reduce, you're going to need to.
This is that 10%.
This is at 10%. Oh my goodness gracious!
Fast.
What happened here? What changed here?
It's variable.
What?
Oh my dear
It's
Lord.
variable for the denominator.
Okay, but same thinking. If the denominators are the same, you add the numerators together. You guys got that?
Yeah.
So we add the numerators together, keep the denominator the same, so when we add, we're going to get something divided by y because that's the common denominator. So you're going to need to add negative 4 with positive 12.
8.
8 divided by y. The denominator is y because it was the common denominator. When you're adding fractions and the denominator is the same, you add the numerators and the denominator remains the same. Okay?
Yeah.
Are the denominators the same here?
Yes.
Yes, the denominators are the same.
But there's very
So we got some stuff going on now.
Jabby do.
I'm changing the subtraction to addition. That's always a great strategy whenever there's subtraction. Change it to addition. And we're going to keep the denominator the same when we add. It's going to be something divided by 11. Can everybody see that? When the denominator is the same. Can you add negative 3x? Oh, that's a 5. Excuse me.
Yeah. Why is there?
Can you add negative 3x and 5 and negative 5? Is that negative 8x?
No.
No, you can't add them together. So what are we going to do?
Negative 3x.
Your numerator is going to be the sum of the numerators if you can't add them together.
Yeah.
But I'm going to change adding a negative to subtracting a positive. So when you're adding fractions that have like denominators, you add the numerators together, keep the denominator same. If you have subtraction, change it to addition. Okay? Simplify if possible. Using the prime factorization is a great way to simplify a fraction. It's probably the fastest and most efficient way.
Guys, we're not 5.
Yes,
Stop.
we are.
I just turned 7.